In this video, I'll be showing you how to solve angle of depression questions. So before we begin, let's define the angle of depression. So the angle of depression is defined as the angle made with the horizon. So the horizon's, oh, yeah, that's our horizon, and the line of sight. Line of sight. So it's the angle made with the horizon, the line of sight when we're looking down at an object. So imagine that's your eye and you're looking down at an object, so say a flower. That angle there, that theta there is your angle of depression. So let's begin with the first question. So our first question is, when an aeroplane is 2 kilometers from the runway, the angle of depression to the runway is 10 degrees. Calculate the altitude of the aeroplane correct to the nearest meter. Okay, so we begin by drawing a diagram. So diagram is the plane. So imagine that's our plane and that's our runway. The plane is 2 kilometers from the runway. The plane is up in the air. So we don't know what the altitude of the plane is, so we'll call the altitude A. But we do know that the angle of depression, so the angle looking down from the plane to the runway, is 10 degrees. So our 10 degrees is outside our right angle triangle, so that's not going to help us when we're when we're using trigonometry. So what we can do is we can find this angle. So this angle here is 80 degrees because 80 degrees is the complementary of 10 degrees. And the horizon makes a 90-degree angle with the altitude. So I'm going to draw the diagram again with just the relevant information. So drawing the diagram again, we have 2 kilometers up here, 80 degrees here, and we have altitude A. So when we're doing right angle trigonometry, we need to identify our sides. So the side opposite the 80 degrees is the 2 kilometers, and our altitude is adjacent to the 80 degrees. So using SOHCAHTOA, we can see that TOA, or the tan ratio, is the most appropriate ratio to use. So TOA stands for tan theta equals to opposite over adjacent. So now we're going to substitute our values in. So that's going to be tan 80 degrees is equal to 2 on A. So what we're doing is we're solving for A. So we're going to make A the subject. So the easiest way of making A the subject when A is the denominator is to actually switch it with the tan 80 degrees. So I'm switching the position of A and tan 80 degrees. A is equal to 2 on tan 80 degrees. And you can input all that into your calculator and you should get 0.352 kilometers. So the question is asking us to the nearest meter, so I'm going to times this by 1,000. So it becomes 326 meters, and we're rounding off to the nearest meter, so it's going to be 353 meters. So scrolling down to the next question. So our next angle of depression question is, when an aeroplane has an altitude of 3,500 meters, its distance from the runway is 7,000 meters in a horizontal direction. Calculate the angle of depression from the aeroplane to the runway correct to the nearest minute. Okay, so we're going to draw this diagram. So the aeroplane has an altitude of 3,500 meters. Its horizontal distance from the runway, so the airplane's up in the air, the runway is down on the ground, and its horizontal distance is 7,000 meters. We want to work out the angle of depression. So the angle of depression is the angle made with the horizon and the line of sight. So it's this angle here. This is the angle we want to work out. Okay, so what we need to know is the angle of depression is outside our right angle triangle. So that's not going to help us when we do trigonometry. So what we do know is the ground is parallel to the horizon. So if the ground's parallel to the horizon, we could use parallel line properties. So we can use alternate angles. And using alternate angles, we know that the angle of depression here is going to be the same as this angle there. So now I want to draw the diagram out with just our relevant information. So we want to solve for this angle theta. It's the same as our angle of depression. We've got 7,000 meters as the horizontal line and 3,500 meters as our altitude. So we're going to solve for theta using those two sides. So before we begin and before we can use SOHCAHTOA, we need to identify the sides. So 3,500 is our opposite side. 7,000 is our adjacent. So looking at SOHCAHTOA, once again, tan is the most appropriate ratio to use. So we're going to substitute all our values into tan theta is equal to opposite on adjacent. So theta remains the same because we're solving for that angle. Opposite is 3,500 and adjacent is 7,000. So our ratio should be tan theta is equal to 3,500 over 7,000. So we're solving for theta. So we need to get rid of that tan. So to do that, we're going to times both sides by tan inverse. So multiplying both sides by tan inverse gets rid of the tan on the right hand side. Oops. So it gets rid of this tan. So theta becomes tan inverse of 3,500 over 7,000. So you can put all that in your calculator. And when you do that, you get 26.56505111. This is our degrees as a decimal. And because the question's asking us to the nearest minute, we use the degrees, minutes, and second function on our calculator. And pressing that, you should get 26 degrees, 33 minutes, 54.18 seconds. Rounding off to the nearest minute, we can see that 54.18 seconds is greater than 30. So we round upwards, so it's 26 degrees and 34 minutes. And that's our final answer.